By now you might be sensing a theme in these notes in that we learn how to do it one way, and then we learn how to do it. Indeed, that's a common theme in math, isn't it? But now that we know that the derivative of e to the x equals e to the x, we know that the integral equals e to the x as well. Just don't forget that plus c for the constant of integration. We want to think about this more generally. Remember back when we were doing our uh, integrals of rational functions, we did a lot of u substitution until we got down to something that looked like this. And we see this over and over and over again. We start saying, oh yeah, we know that automatically, right? So kind of the same deal with this. We would like to try to take these problems out here and use some u substitution to reduce it down to e to the u du, right? So if I'm able to do some u substitution to to rewrite our given integral with this in there somewhere, then we can very easily see that this is going to equal e to the u plus c. So that's kind of the goal here is if we can get e to the u instead of e to the messy stuff, then we're good. So these should be relatively quick because the u value should be relatively obvious, right? It's the exponent. So du dx equals 6, or du over 6 equals dx. So that means that when we rewrite the integral, we're going to have e to the 6x. Well, 6x is u. When we rewrite the dx, we're going to get du over 6. And then we can factor out that 6 that's in the denominator. And hey, look at that. We get e to the u du, which is our formula. So we have 1 over 6 e to the 6x. And then we don't forget that plus c. This next one works the same way. We're going to let u equal... Go ahead and do this one before watching me do it, because I promise you that I know how to do it, but what you want to make sure is that you know how to do it. So use the video to check. Anyway, du over -1 equals dx. So the 3, we're okay with the 3. We'll just factor that out. And we get the integral of 2 minus x is u. Dx is du over -1, or we have -3. And hey, look at that. We have e to the u du. Same as what we had over here. So we've got -3 e to the u plus c, and then we'll just substitute that back, and we'll get -3 e to the 2 minus x plus c. Some of you guys are going to be like, well, why did you bother with the u substitution? I could have done that in my head. And yeah, you can. It's fine. But most of you guys, maybe not most, but a lot of you guys, a not insignificantly small number of you guys, will forget the negative. Because they'll say, oh, it's just linear, it's just going to be 1. No, it's -1, right? The derivative of 2 minus x is -1. So just be careful. And I think that if you're very meticulous about showing your steps and doing your u substitution, then you're less likely to make those silly mistakes. So don't forget we have other strategies as well. Well, actually, I don't know why I said that, because this is the exact same strategy each and every time. I'm not going to work these out for you. I'm going to have you guys start them off. I'm going to start them off for you by telling you what u equals, but you should already know what u equals. The same thing it did before, the exponent. E raised to whatever this is your u value, x squared. Or in this case, u equals 1 over x squared. And for each one of these, you're just going to follow the process of u substitution, and you'll end up with an integral of e to the u du each and every time. So give that a try, see how it goes. Now we start hitting something a little bit more interesting. We could keep on keeping on with our let u equal the exponent, but then we're going to have e to the u over 4 minus e to the u, and then we'll have that extra 1/2 in the mix. But that's not really going to help us much. So I'm wondering if we can come up with something a little bit more helpful to be our u value. It wouldn't be wrong to let u equal 2x. I just don't think it would be very helpful. So maybe we could try using the entire denominator. That's something we did a lot in the last section, right? with our rational functions, a lot of times we just let that denominator equal u. So that's a good thing to try. 4 minus e to the 2x is our u value. So then that means that du dx equals negative 2 e to the 2x, or du over negative 2 e to the 2x equals dx. So when we rewrite this integral, the e to the 2x up top is about to go away. You probably see that coming. And we've got u on the bottom, and the dx is the same thing as du over negative 2 e to the 2x. That's what I was talking about, right? That's what I'm talking about. The e to the 2x is gone, and the negative 2 can get factored out. It's in the denominator, so it's not negative 2, it's negative 1/2. And then we get this familiar integral. It's the other one that I was talking about at the beginning of this recording. So we should recognize this as the natural log of the absolute value. So when we sub back, we get 4 minus e to the 2x inside the absolute value bars. And don't forget, these are excellent, excellent, excellent problems to check using differentiation. It gives you that extra practice that you might need on taking derivatives, as well as checking your answer for the integral. All right. So we've got a lot of different things going on here. So we could let u equal the denominator. We could let u equal the thing inside the exponent. We could let u equal the thing inside the parentheses. We could let u equal a lot of different things. So if you're not sure what to try, then just try something and see where it takes you. Go ahead and give it a try. Pause the video and experiment. All right. Now that you've paused the video and experimented, you might find that letting u equal the square root of x is not very helpful, because we're still going to have this mixture of e's and signs. So I believe the best way to do this is to let u equal e to the root x. And when you take the derivative of e to the root x, you're going to get e to the root x, but the chain rule is also going to put a square root of x in the denominator as well. So that's why this stuff right here is just going to go away eventually. And I'll let you experiment with that and see where it takes you. But remember, the big thing is just to try something and see where it takes you. Even if it takes you to a dead end, you're learning something when you hit that dead end. So start trying things. Just experiment. Same with this. I'm not even going to tell you what u is on this one. You should be able to figure it out. This one I'll help you out with. Maybe you don't need help on this, but maybe you do. This is a single term denominator, so the general strategy here is, if it was multi-term, we don't like that, but if it's a single term, we can just distribute, right? We can divide everything by e to the x separately. And that's a nice thing to do, because then we have 3 baby integrals to deal with. So for example, e to the 2x over e to the x, the 3 doesn't go away, but the e to the 2x over e to the x is e to the x. Subtract exponents. These exponents are exactly the same, so these guys cancel completely out. We just left with 2. And then we could leave this as a fraction. I'll tell you what, I can't tell you how many times I've seen people do this. It drives me batty. They'll say, oh, okay, that is equal to the natural log of e to the x. Come on, really? That's equal to x. Does that make sense? If I take the derivative of x, am I going to get 1 over e to the x? Absolutely not. Don't fall into this trap. It's so common, but it's so easy to check. So easy to check. So don't skip that step of checking your answers, at least in your head. And if you're getting something ridiculous, like 1 over e to the x is always equal to 1 no matter what x is, then notice that it's ridiculous and find another strategy. So we're going to rewrite this not as a fraction, but as 1 e to the negative x. Why is that useful? Well, because that's something that we should be able to integrate, no problem. Each one of these is fairly straightforward. We've got 3e to the x, we've got 2x, and I'm going to hold off on this one. I'm going to go ahead and go through the painstaking step of letting u equal negative x, old-fashioned sort of deal. Old-fashioned meaning we did it at the beginning of this video. So that means that du over negative 1 equals dx. So that means when I rewrite I'll go ahead and rewrite this once, plus the integral of e to the negative x dx. So that means that we get, when we do that sub, we get e to the u times du over negative 1. Well, that's just 3e to the x plus 2x. The negative 1 factors out, and then this integrates to e to the u, but u is negative x. And that's an acceptable final answer, but probably a more acceptable final answer would be to get rid of that fraction. And that would be a nice final answer. If you really felt like it, because the original one was one big fraction, you can get that common denominator, and you can say this is 3e to the 2x plus 2x e to the x minus 1 all over e to the x. And I suppose it's possible that in a multiple choice question this would be the form of the answer. I'm not 100% sure you'd ever see that, but it's something you can consider. We'll do this one on the next video. I don't want to rush it.